High-rise operations, multiple hose lines. This example is very similar to the previous high-rise example, with the addition of a second hose line on the fire floor. There are two 50-foot 2.5-inch supply hoses, the gated Y, and two 100-foot 1.75-inch attack lines flowing 150 GPM fog nozzles. The fire is on the 9th floor. The attack crew is flowing two 100-foot 1.75-inch high-rise packs with fog attachments. Do not forget to use the conversion factor for 1.75-inch hose when setting up this problem. Also, make sure to account for the system loss, gravity loss, and appliance loss for the gated Y on the fire floor. Pump pressure equals nozzle pressure plus friction loss rate times length for the supply plus appliance loss plus friction loss rate times length for the attack hose lines plus system loss plus gravity loss. So pump pressure equals 100 plus the friction loss rate times 0.5 for the 50-foot supply hose line plus 5 plus the friction loss rate times 1 for the attack lines plus 25 plus 40. First, we'll determine the friction loss rate for the 2.5-inch supply hose line using FLR equals 2Q squared, where Q equals 150 divided by 100, since the total GPM is divided by two supply lines into the FDC. Therefore, FLR equals 2 times 1.5 squared, where the FLR equals 4.5 or 5 psi per 100 feet of hose. So to determine the 1.75-inch attack hose line, we'll use FLR equals 2Q squared, where GPM equals 150 times 2 for the conversion factor of 1.75-inch hose. So Q equals GPM divided by 100, in this case 300 divided by 100, which equals 2 times 3 squared, when the friction loss rate then equals 18 psi per length of 100 feet of hose. So pump pressure equals 100 plus 5 times 0.5 plus 5 plus 18 times 1 plus 25 plus 40. So pump pressure equals 100 plus 3, which is 2.5 rounded off to 3, plus 5 plus 18 plus 25 plus 40, which equals 191 psi.